So today what we're going to do is talk about naming. And naming basically comes down to a couple things. If you try to make it complicated, it can be. So the best way to approach naming is to use the periodic table as a guide and then really try to work on breaking things up. And so the first slide I have here shows the basic blocks of the periodic table. And so the first two blocks on the far left are called the S block. The middle part of the periodic table is the D block. The far right is called the P block. And then underneath the periodic table is the F block. The other way to make naming really straightforward on top of knowing the blocks is knowing the staircase. So the staircase runs along the periodic table here. And what it does is it separates the periodic table loosely into nonmetals, which are in the upper right of the periodic table in this kind of yellow-orange color, from the metals, which are these green items that are below the staircase and to the left on the periodic table. And then along the periodic table is the metalloids or the semi-metals, but it's good to kind of keep this apart because if you keep track of where things are on the periodic table, that'll really bring into focus how to name something correctly. So we're going to start off real basic when it comes to naming. And really basic naming comes down with forming a element from a metal element from the S block with a non-metal element from the P block. Or if you look at the one with the staircase, it's going to be the S block, and then the non-metals, which are going to be the items that are going to be above and to the right on the staircase. Now, with ionic naming, what happens is when you bring those two elements together, the metal always gets named first. So if we were bringing sodium and chlorine together, it's always going to be sodium followed by chlorine. Chlorine will never be first. So you're always going to have the metal first. And then to represent that they're bonded together, you change the I and E to ide. So sodium chlorine becomes sodium chloride. And then the corresponding formula would be NaCl. Now, when we look at magnesium chloride, so we already know we have magnesium and chlorine bonded together. It's important to look at the charges that you can have on the periodic table. So I'm going to post a periodic table with charges, but loosely, what happens is that the column 1 is +1, the column 2 is +2, and then the D block can vary, so we're going to skip over that. 13 is always a +3, 14 is a plus or -4, 15 is 3 minus, 16 is 2 minus, 17 is -1, and 18 is 0. So I'll have a periodic table posted in Canvas. You want to see this, see those charges, but it's good to keep those in mind. So going back to this example here, magnesium chloride, magnesium is in that second column, and it's going to be Mg with a 2+, and then chlorine is going to be Cl with a 1-. And the way that some students remember this is by the crisscross method. So we have the +2 over magnesium. You're going to take the number, not the charge, and move it over to chlorine. So in this case, chlorine will have 2. Chlorine has a -1 charge, so when you cross it over, magnesium will have 1, so it'll be MgCl2. And the goal at the end is always to balance the charges. So because Mg is a +2, we need Cl to have a -2 to balance that out, and therefore we get Cl2- from that, or MgCl2. For calcium oxide, calcium is in column 2, so it's +2. Oxide is in column 16, so it's -2. But in this case, if you were to cross them, you get 2 and 2, and you reduce. So calcium oxide is actually CaO, not Ca2O2. So in ionic, always make sure you reduce to the common level. When it comes to polyatomic naming, I have a whole item on polyatomics, so I have a different PowerPoint. There's a list of polyatomics you will need to know, and I'll go through when the quiz will be over that. And then I also posted a Quizlet to assist you when it came to knowing the polyatomics. So it's going to be crucial to kind of recognize like what you need for that. But just briefly to go through polyatomics, what's going to happen is when we do the crisscross method, so we have magnesium nitrate, we have Mg2 plus and NO3 1 minus. When we crisscross this over, you're going to end up with 1 magnesium, and you're going to end up with 2 nitrates. And again, we don't want to show the nitrate is MgNO32, so you need to actually have some type of orientation or some type of notation to indicate that. So in chemistry, what happens is we put parentheses and then a 2. So this is Mg in parentheses NO32, and this represents we have 1 magnesium and we have 2 nitrates. So what I want you to do is go ahead and try to write the formula aluminum hydroxide. Go ahead and pause at this point in time to do that, and then restart it, and then I'll have the correct answer after the pause. So aluminum hydroxide is going to be AlOH3. Hydroxide is a polyatomic. It's OH with a -1. Aluminum sits in column 13, so it has a +3. So when you do the crisscross method, you're going to need 3 hydroxides and 1 aluminum. So therefore, it's AlOH3. All right, so here's some practice for you guys. So I have a couple items here for you guys to practice. Let me bring these up. So I have 5 items. Go ahead and pause the video and then go and restart it, and then we'll have the correct answers on the next slide. All right, here are the correct answers. So to review these, NH4 is a polyatomic. It's ammonium, and it's with Cl, which is chlorine, so it's going to be ammonium chloride. Potassium nitrate is a polyatomic. Potassium is K, nitrate's NO3, so it's KNO3. Calcium sulfate, calcium is Ca2+, sulfate's SO4 2-, so it would be CaSO4. Mg in parentheses HCO3 2 is going to be magnesium hydrogen carbonate, so that's what that is. And then magnesium acetate, magnesium's Mg2+, acetate C2H3O2 with a negative sign. When you cross it, you're going to get Mg C2H3O2 in parentheses 2. So let's move on now to other ones. So there are other atomic compounds, or other ionic compounds, and these items actually will be items from the D block, and then you're bonding it to an item from the P block. So in our previous example, it's the items here in the D block are underneath the staircase with the items above the staircase, and because they can vary, that's why you need Roman numerals there. So for instance, you can have iron 2 chloride. Iron 2 chloride is going to be Fe2+, because the 2 represents the charge it has. Chlorine will always be Cl1-, so when we crisscross that, we're going to get FeCl2. Then we have cobalt 2 oxide. Cobalt will be Co with a 2+. Oxide is O with a -2. So when you cross and reduce, you're going to get CO and then a capital O to represent that. Here are some examples to do. So we have FeS. S is sulfide or sulfur. Sulfur will have a -2 charge. Since we only have 1 iron, iron has to be a +2 or iron 2 sulfide. We have cobalt chloride here. Chloride is -1. There's 2 of them, so therefore cobalt has to have a +2. So it's cobalt 2 chloride. Just to review ionic naming, So ionic is broken up into kind of three parts. One is you have no Roman numerals at all. You're going to have items from the S block. If you have Roman numerals, you'll have a metal from the D block or under the staircase. And then polyatomic, you're going to need to use the polyatomic sheet. So ionic is usually the harder one, so we'll be doing a lot of practice with these, various worksheets and activities and things like that to sharpen and get better at this. The other type of naming is covalent. And covalent naming is straightforward. It's pretty straightforward and pretty easy. And all the covalent naming, you have items that are all above the staircase. So it's all these elements that are going to be above the staircase circled in red here. And where covalent naming differs from ionic is that for sodium chloride, there's only one correct orientation for sodium chloride, and that's NaCl. You cannot have any other orientation. There's always Na plus, Cl minus, we have NaCl. With nitrogen and oxygen, you can't just say nitrogen oxide. That can mean a variety of stuff. You could have NO, NO2, N2O2, N2O4, and like there's at least 4 or 5 other items that could be nitrogen oxide. So for covalent, we had to come up with prefixes to make this work. And so the first prefix, mono, our no prefix is 1. And I think the way to think about this is monotone. I'm sure some of you have sat through monotone presenters where they just have like one tone throughout the entire lecture. It's kind of challenging to pay attention. Di is 2. Tri is straightforward because it's 3, like triangle or triceratops. Tetra is 4. And many of you have probably played the game Tetris on your phones. You might be playing it in class as you listen to this. But Tetris basically received its name from having 4 distinct shapes. Penta is 5. So we have the Pentagon in Washington, D.C. to represent that. Hexa 6. Hepa 7. And then Octa, for those of you that drive, is highly important. An octagon is a stop sign which has 8 sides. And so octa is 8. For covalent practice, again, it's straightforward. The prefixes and the numbers give you the prefixes. And so there are these 5 items here to name covalently. Go and pause the video, try to name these 5 things, and then I have the answers. Okay. So N2O4 is dinitrogen tetraoxide. PCl5 is phosphorus pentachloride. Dihydrogen monoxide, tried to trick you. It's just water, H2O. Carbon monoxide is CO. And then CO2 is carbon dioxide. So to review covalent, it's all items that are from the right of the staircase on the periodic table, and hydrogen's included in there too. So now what I want you guys to do is practice. So I have a whole list here. There's a whole ton of these. It's all mixed up. So what I want you to do is go ahead and pause the slide where it's at, work on these problems, and hit play. And then I'll have the answers on the subsequent slides. Okay, here we go. So sodium sulfide. Sodium is Na with +1. Sulfide is S with a -2. When we cross, we're going to have Na2S. Potassium sulfite. Sulfite's a polyatomic. It's SO3 with a -2. Potassium is K with a +1. So when you crisscross, you're going to get K2SO3. Cobalt-2 phosphide. Ide indicates it comes from the periodic table. Phosphorus has a -3 charge. Because it's cobalt-2, we know it has a +2. When we cross, we're going to put a 2 over here with the phosphorus, and the -3 phosphorus is going to be over here with the cobalt, so it's going to be CO3P2. Iron 3 hydroxide, we're going to have Fe3 plus and OH -1. When you cross that, we get Fe in parentheses, OH3. Dinitrogen dioxide is going to be N2O2. Silver bromide is AgBr. Then for the next group, We have N2O4 is dinitrogen tetroxide. ALI3 is aluminum iodide. MgCl2 is magnesium chloride. NiHPO4. HPO4 is a polyatomic called hydrogen phosphate, and it's nickel. And then MnS is manganese 2 sulfide. And CN2. CN is a polyatomic, it's cyanide, and SR is strontium, so it's strontium cyanide. So this last slide here is just a review of everything we covered. So in ionic, it's important to separate what you have. No Roman numerals, no Roman numerals will be S block. Roman numerals are D block metals and some below the staircase. Polyatomic come from the sheet that I provided. Make sure to memorize those. And covalent are all the items from right of the periodic table and hydrogen. So we'll do a ton of stuff with this to make sure you're good. This is just a summary of this topic. So make sure to look at this and go along with the worksheets. And again, naming is straightforward but can be confusing. So I try to break it up. And we'll spend time covering this topic over the next couple days.